Sorry about that. I just kicked everybody out. I hit the wrong button, and you know what? That's going to happen. Boy, it might even happen in week 7 for all I know. So that is going to happen. I'm sorry about that. Sorry about that. That was bad on my part. So, did everybody get the right answer? I am going to show you the answer. And this is what I got. So check your answers against mine. See how you did.
So when you're doing problems like this, Doug,
yes,
is it best to kind of keep, like, how many decimal points?
Well, you know, that's a good question. And listen, if we're close on our numbers, if we're this far apart on our numbers, we're going to call it absolutely good, okay?
Yeah, because we had like a lot of the same answers, or different answers, but you can tell everybody's doing it right. They're just using.
Yeah, just it depends how much you round it up or round it down. So if you're close, call it good. How's that?
Okay.
Okay.
Cool.
How's everybody thinking? Are you getting the right answers though? Is everybody there?
Yeah, pretty much bang on.
Perfect. Perfect. So that was my first little foray into making breakout rooms, and then I failed miserably when I cut everybody off. So we'll continue to maybe do something like that in a future date. So it brings us to a break time. So I'm going to stop sharing here for a second. Again, now we will take a break here. Okay, we'll take a break. Stretch your legs, get some water. We're going to go over a few more things, and then I will release the assignment on D2L for you guys to complete. All right, so like I said, take a break, come back 10 o'clock. Okay, 10 o'clock. Is everybody good? So we'll resume recording. Because I exited out of Zoom, unfortunately, we're going to have 2 recordings of today's lesson. I'm sorry about that. It is Friday, so let's take it easy on each other. At least me, anyways. Yeah. All right. Okay, so is everybody back? Hopefully everybody's back. Everybody's back. I can only see a bunch of blank screens on most people, but hopefully everybody's back. So I'm going to share a screen here again to start us off. Now we need to understand some language that this talks about. So first off, let's go to Archimedes' principle again. So Archimedes, the Eureka guy, reasoned that the buoyant force acting on a body reduces the weight of that body equal to the weight of the liquid the body displaces. So that's how he came up with his how to weigh this crown, is that he used the displacement of the fluid is directly related to the volume. So he calculated the volume of the crown according to how much water it displaced. So now we have to talk about the 3 laws of buoyancy here. Okay, so this is right out of your ILM. So the 3 laws of buoyancy. Number 1, a body sinks. So when it says a body sinks, I'm not talking about Donnie McKenzie or anything like that. I'm talking about the object. The object sinks in a fluid if the mass of the fluid it displaces is less than the mass of the body. Okay, so that kind of makes sense. So this is some of the language that we have to get around. Now, number 2, if a body displaces a mass of fluid greater than its own mass, it will float. Pretty straightforward on that. And number 3, a body remains in equilibrium, neither rising nor sinking, if the mass of the fluid it displaces is equal to its own mass. Okay, so there you go. And if it's 1 and 1 at the same, then it will just kind of float there in equilibrium. So there is a couple of other ones that I want to talk about here. And can everybody see that screen where I have buoyancy on there? No?
Yep.
Yeah? Okay, so this is some of the language, these points to remember. Okay? This little points to remember. So a body immersed in a fluid loses the same weight as the weight of the fluid it displaces. So that's how I can sweep my girlfriend off her feet in the swimming pool. Is because when she's submersed in that fluid, she becomes a lot lighter. So number 2, an object will sink in a fluid if the weight of the fluid displaces is less than the weight of the object. So that's another little way of twisting these words. And this is some of the questions that you're going to be asked in the assignment has these types of words like this. So an object will float if the weight of the fluid displaced is greater than the weight of the object. So if I was to do an example of this one right here, if I was to do an example of this one, think in a swimming pool full of water, and I put a beach ball in there. Oh, I'm drawing on 2 separate pieces of paper. I don't even know how I'm doing that. So if I had a beach ball, let me see if I can get that back together. If I had a beach ball in there, that beach ball is going to only displace a very, very small portion of water. This much. It's only going to displace this much. But that object, let me just get rid of my annotations here. I don't even know. Okay. That object, so the object will float if the weight of the fluid displaced is greater than the weight of the object. Now, when it says displaced, it means I have to get that ball in here, in the water. And that ball, if it's 1 cubic foot, will displace 62.4 pounds. That's how much water that this ball will displace. But the ball only weighs 1 pound, so clearly it will float. And then the last one, an object will remain in equilibrium if the weight of the fluid displaced is equal to the weight of the object. There's a little more points to remember on this, and that's at the bottom where 1 cubic foot, 62.1 gallon, 1 cubic meter, 1,000 kilograms. Okay, these are the numbers that you need to remember for sure. Now, where did I find this buoyancy points to remember? Does anybody know?
In the one flip book.
It's in the Formula Triangle booklet. Yes, indeed. And with this booklet comes a little formula triangle here. Okay, so if you use this Formula Triangle book under buoyancy and use those formula triangles with these points to remember, you should be able to complete the assignment number 5, water properties and buoyancy.
Where are those at in the booklet, Doug?
In the formula triangle booklet, it is one of the pages in there. And you can find that in D2L under formulas, and you'll find that formula triangle book, and it is in there on page, I think, 12 or something. Can't actually.
5 pages from the back. Yeah, I mean,
So use this these formula triangles and these points to remember to do the next assignment. And I'm going to pull that assignment up here. Share this screen. Okay, so here I am back in D2L. This is the ILM. But if you go into assessments under tests, you can see now assignment number 5, water properties and buoyancy, is there for you. Now to find this formula triangle booklet, if I was to go into content and I go into formula sheets, formula triangles, and it is in one of these right there. And there it is. I don't know why the first one isn't populated. Should say buoyant force. Okay, so now, everybody, it's Friday, the end of week 2 for math. Anyways, we have math the same times next week. Look for a Collaboration Sunday Zoom meeting on the front page of D2L. I'm going to put that on there today. I'm going to set up a Zoom meeting so you guys can Zoom in and chat about any subject matter you want. It'll be on your math D2L front page. I'll set that up for 8 a.m. Sunday morning. And I'll be around a little bit for this one until football starts probably. Anyways, it's a couple hours of collaboration. Please log in if you have any questions on any subject. Maybe somebody in the room can help you. So I'll put Collaboration Sunday on there. This next assignment, number 5, is due by the next math class. So you have to have it done for Tuesday. Yeah, Tuesday afternoon is our next math class. Now, we also have math tutoring Tuesday morning, starting at 6:30 a.m. It should be a recurring calendar event in your calendar, the math tutoring. Do you have any questions for me before I let you go to do that assignment? Any questions?
Yeah, when we just did that one in the group there, how did you get the 0.666 squared?
Well, that would be the diameter was 16 inches. And so because we're doing cubic feet for volume, I had to convert that 16-inch diameter into feet, which is 1.333 feet. And
Okay.
then that's the diameter. So the radius is half of that. So that's 0.666.
Okay, thank you.
All right. Okay, so now I'm going to let you guys have some time to work on assignment number 5 in D2L. So you'll find it under the test heading, assignment number 5. You will also find a paper PDF copy, if you will, if you want to print it off, under assignments, number 5. You can find the PDF version of that test. So you are to enter all of your marks before Tuesday 8 a.m. class. You will have it done by then. Okay? And that, everybody, is it for today for me. I know you have an afternoon class, so do what you need to do to get ready for that. I know it doesn't start till noon, so it gives you a little bit of break, gives you a little bit of time to work on this assignment, okay? And if you have no more questions for me, have a great weekend. We'll maybe see you Sunday, maybe not. Maybe, you know, maybe the next time I see you is Tuesday morning, 8 a.m. All right? Have a great weekend. And thanks for your patience.
Thanks, Doug.
Thanks, Doug.
Yeah,
Thanks,
anytime.
Thanks, Doug. Have a good weekend.
Thanks,
Yeah.
Doug. Have a good weekend.
Thank you.
Thanks.
Thanks, Doc. Have a good weekend. Yeah.
You too.
Thanks, Doug.
Thanks, Doug.
I'll hang around for a bit if you guys want anything from me or something.
Yeah, Doug, I'm trying to do that 0.666. I don't know how to get that. You said that's going to be the diameter in half, which is going to be the radius.
That's correct. So that's the radius. Half of the diameter is the radius. Here, I'll share my screen here.
This is the diameter 16 inches.
Right. So we converted
Oh,
the
we had to put that to feet. Oh,
That's right. There you
oh
go.
shit. That's what's happening. I'm sorry. That's